Hi, my name is Sachindra, and I'll be talking about the final assignment of the AI Product Management course, Managing Machine Learning Projects. The opportunity that I want to talk about is the challenges faced by the car dealers. So there's a whole lot of cars that are bought and sold in India, and before selling, they're stocked in the dealers' warehouses and then sold. There are a whole lot of options that are available, and dealers have a hard time ordering, the right combination for the cars. So the challenge is, which combination of the features to order, for the cars to minimize the time to sell and have the maximum margin. Can ML help solve it? So we need to find the right configuration of the features that would be most attractive to customers in the dealer's area, and that's the bigger challenge. There is data available on sales transactions, days on lot, margins, configuration of cars, and all that. ML is a great option to find a solution because there's large amounts of data, there's large amount of features and complexity for the prediction model. Does someone care? There are two stakeholders, the dealer, because they want to maximize the margin and reduce the cost of keeping the vehicles in inventory, and the car manufacturers because they want to increase the sales velocity so that they can sell more vehicles. Now, for the crisp DM business understanding, we do have our target users, dealer manager, and OEM sales managers. Problem statement: predict the cars which have the highest probability of selling quickly and at a high margin, or cars to avoid those with lowest days to sell and lowest margin. Why it matters? The cost of maintaining vehicles on lot is high for dealers. Cost of capital, insurance, cleaning space, opportunity costs, etc. The impact on OEM revenues is very relevant. The faster they sell cars, the more cars that they can sell. The way it's solved today is that the OEMs and dealers decide which cars, which configuration to go for based on heuristics and gut feel, which is not very effective. We see lots of cars, staying in lot, and dealers have to give discounts to sort of move them out and all that. How do we measure success? So we predict the cars that will be moving off the lot faster and have more margins, thus increasing the revenue for both the dealers and the OEMs. The solution description of how ML is used. So we collate the data, we identify the key heuristics and relevant factors for predicting the cars to order by talking to dealer managers and OEM sales managers, which features would make sense. Perform exploratory data analysis to identify the relevant features using various visualization, statistical methods to confirm the manual features used, and if there are any dependencies and all that. For model selection, we traveled with simple models first based on current known features and test for speed and accuracy of prediction using, say, regression or decision tree. And then select a model which meets the required outcomes better. The process flow for interacting with the model. So we build an UI for the dealer managers and OEM sales managers that interfaces with the data and the model and provides the output prediction to the users. For the validation plan, the initial model testing will be done by comparing the output of the model with the heuristics outcomes which they're currently using. This approach will be used continuously with multiple iterations of the model. When at least 90% of the car predicted by heuristics are there in the model, then the model will be tested with a different target audience, a different dealer managers. And if the results are acceptable to a panel of expert users, then the ML model will be moved into production. For production deployment, we'll use the A/B testing approach. So both heuristic outputs and the ML output will be active for a while, and we will compare the results and refine the models. Once the expert panel says that, yeah, the results coming from ML model are acceptable, then only the source will become available. Then ML will be the only source available. For ML system design, these are the design decisions that I've taken. So cloud versus edge, I've chosen cloud because some latency is there, but that's acceptable. Connectivity is usually good. Cloud security is good as well, so no security concerns are there. Online versus offline batch predictions, I've chosen offline. because the model needs to return the predictions for the cars to be ordered at a weekly basis. So there's no need for real-time predictions. So offline is much better. And we still need to rely on monitoring to uncover any model drifts. Online versus offline learning choice. I've chosen offline here again. It's easier to implement. The amount of data being handled is smaller, than the big data. We need to schedule jobs to monitor the data and concept drifts, adapt to any changing environment. And we need to retrain the model periodically based on performance thresholds. Potential issues that might be there in production. Data quality issues. We could have the quality of data coming in from the feeds that might be challenging. There might be changes in the market environment. The region is shifting from sedan to say SUVs, for example. How to manage the issue, periodic manual edits and quality checks. Model decay. So the model performance over time is likely to decay. Model decay usually happens because of changes in environment or bias. The way to manage this is to monitor the model performance, look for changes in distribution of actual versus predicted output, and initiate model retraining if performance goes below threshold. Bias, there could be bias in existing data on which the model was trained. The way to manage this during the model design, updating, or retraining, penalize the features that are prone to introduce bias. And during and after the model design or implementation of the system, predictions to understand logical reasoning, for the predictions that are coming in. And that's all that I have for today.